从 NumPy 嘛。那其实像 Pandas 是更使用者面向一点，更比较偏向应用层一点的 Python package。如果大家有在做资料分析，应该都会了解。那也跟上一场的讲者一样，就是其实 Pandas 的就是里面的结构有很多都是来自于 NumPy， 那不过就是比较应用层的。那在这里的话，我们就请到Zong-han帮我们详细的就是讲说，那如何应用 Pandas 在我们的就是资料分析的应用里面的用途。那就请大家掌声欢迎他。
Okay, thank you all guys to be here and listen to my talk. And today my topic is practical data transformation and analysis with Pandas. Okay, first it's about me. I was majored in physics, and my first job is developing numerical algorithms in LCD manufacturer. I'm an R&D engineer. And currently I'm working for the Micron Memory Taiwan. It's based in Taichung, and I'm building a department, BI system for our own department with Pandas, Django, and some database package, something like that. Okay, and today I want to talk about this because I want to share this talk based on some of my work experience. Because in the major and large company, the older reporting system are all based on SQL, and sometimes you have to do some data transformation, data analysis, and they are all written in the SQL code, and it's very hard to maintain. I have seen some SQL code like 1,000 lines and a dozen of temp table in it. I don't even bother to trace that code. You still need SQL so you can query the data from the normalized RDB, but you need the logical part. You can write all the logical part in Python, and the code is more maintainable. Okay, so this talk is intended for those people who will do the data analysis. Maybe previously in SQL, okay, and now they are using Python, and I will mostly address on the Pandas functions that is analog to those concepts in the SQL. Okay, so here's the outline, and I will start with the basic data structure in Pandas, just some basic components. And of course, you are handling data, so you have to handle the text data. So the second part is about text data handling. And then in SQL, you will do a join and maybe union all. That's very basic in the SQL. So in Pandas, you have merge and concate, and I will talk about this in the third part. And then the most important feature that we used in SQL to transform and analyze data is using the group by, and you can do some statistics with the data. And in Pandas, we use the split, apply, combine strategy, and I will talk about it in the fourth part. And in the final part, I will give some simple example using Pandas and compared to SQL code. Okay, so I will quickly go through the data frame basic component part. So in Pandas, you store data in a two-dimensional table. In Pandas, that table is called a data frame, and it has columns and rows, just like a SQL table. And every row is labeled by the index. So let's say I have a column A and a column B. The data is here. So you can call the data frame and use a dict to produce a data frame, and you can label each record with this index. And okay, and if you know how to use NumPy, you can transfer the NumPy array into a data frame, because they are basically they all share the if you use a two-dimensional NumPy array, you can transform that into, you can directly put that into a data frame. They are basically all two-dimensional objects. Okay, two-dimensional arrays. So you can throw a NumPy array directly into this data frame function. Okay, so if you want to create a new column in your data frame, you should use, and you can directly use. I created a data frame first with 2 columns, and then I want to create the 3rd and the 4th columns. You can use the you can use this syntax to create the new columns. You can assign a Pandas series, which is a one-dimensional data structure that is similar to the NumPy array, one-dimensional NumPy array, and you can use a value directly. Then all the value in this column is equal to this value you assign. And you can also read data you can also read tabular data directly from a CSV file. And here is the syntax. I'm using the movie lens data for the demonstration today because I can take out the company's production data. Yeah, and I need to demonstrate some properties like join. So I selected this movie lens data. And okay, so it's basically a CSV type data, except that it has some strange delimiter. Okay, so in this function, you can read a CSV file into a data frame, and I will talk about this index functions later. Okay, so I have 3 files to read. The first file is about users, which mapping the user ID and its age to its every user ID and every user's gender, age, occupation, and its zip code of his address. And the second part is movies data. Movies data contains a movie ID and the title for this movie and its genres. The third part is the ratings, which is the user will rate a movie with a score. So this is the part that relate user ID, movie ID, and the ratings the user gave, the user gave, and its time to, and the time that user rated this movie. And I use this timestamp is actually in unit of seconds, starting from Unix epoch time. So I use the Pandas today time to transform this number into a Python datetime format, Python datetime object. Okay, so you can create your own data frame. You can read it from a CSV file, but mostly in company you probably want to read that data from a SQL database, and probably you will write it back to a SQL database. So, but here I don't have a SQL database, so I use SQLite 3. You can change this SQLite 3 to other database package like PyMS SQL or CX Oracle. I have tried these 2 packages. Okay, so this is to write your table into a SQLite file, and then you can use the query string, SQL query string, and the read SQL function to read the table back, to read those tables back. Okay, and every data frame has an attribute called columns. You can use columns to it will return a list-like object, so you can know how many columns and what are the columns inside this data frame. And okay, you can change the order of this data frame, the column order of this data frame by by directly assign a new order into this column attribute. Okay, at the beginning we talked about the data frame. The data frame has a every record, every row has an index that is labeled to this, that the label that data frame used for this record, for this row, and you can use the index attribute to retrieve the index of this data frame. Okay, now you want to get value out from this data, get the data out from this data frame. So you can directly using this syntax to get the data out. It's like using a two-dimensional array or one-dimensional array. Yeah, the first dimension you enter is the column, and the second one is for the index. It's which row you are. The first syntax, the first part, you get a Pandas series. You get a one-dimensional array, and then you use another index to retrieve a particular value or a particular range of the value, a particular range, a value in a particular range from this Pandas series. Okay, so you can acquire multiple columns at once, but you have to remember that most people will forgot to use a list inside this syntax. You cannot do this. The code you cannot use this. It has to be a list inside that bracket. Okay, and you can retrieve a column without using the bracket. You can use the attribute. The column header will become the attribute of this data frame, so you can use attribute to retrieve the data in a column, and it will return a Pandas series. Okay, so these are okay. This is probably duplicate. Okay, so I'm going to talk about the most important two concept that uses indexing a particular a value inside a data frame, a data inside a data frame. And there are two ways you can specify the positions of the data you want to retrieve. You can use a label-based indexing or a location-based indexing. A label-based indexing is just using the index. This is position-based, location-based indexing. You have to use the iLocation function, iLocation attribute of this data frame. Okay, and in the first statement, I sort the values according to the time the user rated this movie, and I sorted in a descending order. So when I used the top 10 items, that you will give me the newest the most recent 10 records. Okay, this is based on the position. This data in the positions of this data inside the data frame. And in this page I didn't specify the columns I want, so I use this syntax. So all the columns I will retrieve all the columns. But if you want to retrieve certain columns with iLog, you have to use integer-based list, because in iLog everything is based on the position of this data inside the data frame. So you cannot use the name of the header. You have to give it the position, like the 0th column, the first column, the second column. And besides the iLog, you can use the log attribute, which is a label-based indexing. If you use this log attribute to retrieve data, it is not based on the position where the data is inside the data frame. it is based on the index of that record. So when I want from 0 to 100, but it will give me this much data because from 0 to 100, but I have sorted the data, so a lot of other data was now ordered. We ordered between the 0 index and the 100 index, so I will get this much data when I use this statement. So if somebody have wrote SQL code, some SQL code, a very common syntax is like this. You use where condition to retrieve partial data from a SQL table. And now you can do the same thing in data frame. You simply use this syntax. This syntax will give you a truth array filled with Boolean value, just like in the last session that Tim has showed us. It has exactly the same effect. So the ratings DF will take this Boolean series, and it will only the value with truth value, only the records with truth value will be retrieved. Okay, but a lot of value there, a lot of data there, so I use ilog function to retrieve top 10 records. Okay, so you can also specify a range where the data you want. And in this case, I specified a range for with the date time. So so I specified the range. So I used two conditions, like the data will have to be between February 1st, 2003 and January 1st, 2003. So okay, so this is basically the conditions, and you have to use bitwise and it has override this operator, so it will directly do the bitwise and to these two Boolean array, to these two Boolean series, element by element. Okay, so you will get the same effect as the SQL code on the above. Okay, and you can, and I printed the maximum, the latest time and the oldest time within this range. Okay, so it's the latest record is in January 31st. It's around 5 p.m. and the oldest record within this range is in January 1st, and it's 1 p.m. 1 a.m. Okay, and I just found out this because I believe that many people have used this IX attribute, but in the latest version of Pandas 0.20, this version, and in this document, it has explicitly mentioned that this function this attribute has been deprecated because it do a lot of it will confuse the user, because it will judge if the user is using the location based or index based automatically. So the pandas is going to deprecate this attribute. So I suggest that if you if you are going to use pandas, your index have to be clear using the log attribute or ilog attribute. Okay, so oops. Yeah, this is strange. Oh, okay. Okay, so you might sometimes see you want to change data in the data frame. So you in an intuitive method, you will index in this you will retrieve the value from this data. You will assign a value to this data frame with a specific indexing. But sometimes this index sometimes the syntax may not work as you expected, because in this case I assigned I want to change all the gender value to female for all the users that with user ID less than 10. But if you print out the results, a lot of data it has no effect to this data frame that I showed here, and it showed a warning called settings with copy warning. Setting with copy warning. You can find in its official document that if you are doing consecutive indexing like this syntax, and it will call two functions consecutively. So, but in Pandas, it makes no guarantee that the function that it return the data it returned is a copy of the original data, or it's the view of the original data. If it's the view of the original data, you are modifying the same memory address. But if it's the copy, then you are just changing a temporary copy in the memory, and it has no effect to the original data frame. So if you want to change the value inside the data frame, do not use a consecutive index. Instead, you use log or ilog attribute. In this syntax, you can change the value successfully, because you do not use so in this case you will return a view, and you will change the data directly instead of changing the copy. So so you can, in this case, as I demonstrated, you successfully changed the gender value within the top 10 records. Okay, that's some about the Pandas basics. It has cost me almost 20 minutes. Okay, so so I'm demonstrating some text handling. Okay, this is nothing. This shows the table that I just showed in the previous slides. Okay, so you can I want to retrieve the movies which contains a toy stream within its title. So I can use this stream attribute of a Pandas series, and which use the contents method of that attribute, and then I ask it returns a Boolean series which will tell me what movies are using which movies are containing a toy string in its title. Okay, and I got these movies. You can also use a regular expression when you are using some of the functions in the string attribute. In this case, I asked it. I wanted to retrieve the movies with a space. The toy string will have a space. Will have this movie title. The title of the movie will have a space before the toy word. So there are only two matched records to match the data in here, Toyland, and I believe that the toy words is somewhere in here, somewhere within this string. Okay, or you can ask this contents function to find the movie title that starts with the toy string. Okay, and I got Toy Story and Toy Story 2. Okay, and you have a split functions which will expand it will split the string based on the delimiter you specified, and it will give returns a list that contains the splitted string. And in this case, I wrote a two-layer for loop to expand the movie genres to into different records. Okay. And you can also use the add operator to concate strings. In this case, I concate the movie titles and the movie genres, and they give me this string. Okay, so we are moving to a how to merge data in the concate. Okay, it's actually merge data frame or concate data frame. Merge is just like SQL join. Okay, so if you all people have written some SQL code, you may be familiar with this with this concept. So the syntax in the pandas to merge two tables, they are very familiar with the syntax in the. They are based on the same concept in the SQL code, so you can merge two tables and we specify the key for it. And in this case, I use the left join. Okay, so I joined the three tables together. That is the ratings and the movies and the user table. I join them together, so I know that. So I have a complete data that the. Okay. 现对。Okay, so in this case, I merged the three tables together, so I get a complete table of all the data I want. We merged the table that containing ratings and ratings information, users information, and movies information. Okay, and then this is a simple demonstration to concate tables. I create two data frames, but the behavior has some difference between the SQL code and the pandas here, because in SQL code if your columns are not match, you cannot use union all to union these two tables. But in pandas, if you use the concate functions, the matched columns the pandas will fill in the they will fill in the NaN numbers. It's NumPy's not a. It's NumPy's. It's in the NumPy definition. It's NumPy's not a number, but pandas using this value to represent the null value inside the data frame. Okay, and to go to the last part, I use about the split, apply, and the combine process. Okay, in SQL we use group by to aggregate data. So, but in pandas we have similar concept. We split data with the group by functions, which is a attribute in the data frame and you apply a function to the data within each group, and then you combine them back together. Okay, in SQL code, you're most likely to do this kind of syntax to aggregate data. In this case, I want to know the average ratings of each movie. Okay, so you can use these two syntax, but in the pandas, you are using the group by and transform function. Okay, but in this case, in this syntax I use the transform function, but actually you can use transform or an aggregate function. Okay, let's start the last part. Okay, you can use the group by to a data frame, and it will give you a data frame group by object, but you don't know what it is. So I used the for loop to look into it, and it will. Okay, you will give you. It actually contains two data. The first in each two data in each group. The first part is the key that which this group is the data containing in this group is all with this key. We all with these values in this key, and the second one is the data frame that containing all the data within this group. So with this information, I can do split, apply, and combine strategy manually. So I using a for loop to go through it. But actually, you don't do this. Okay. What is this? Okay. Okay. Sorry. This is an. I think this is an extra text, extra slide. So you can use a group by, and you specify the columns that you want to get a mean value with it. It will return a pivot table that contains the mean value. But you can flatten that pivot table by using the reset index. Okay, and after you flatten that table, you can merge it back to the original data frame and continuing the processing. Okay, and okay, let me check. Okay, and there's an aggregation attribute in the group by object that is you can specify the columns and the function you want to apply on the data of that column in that column. Okay, in this case, I want to know the mean value of the movie ratings in each type of the movie and in each occupation of the people. Okay, so I use this, so I get this result. And okay, you can. The best part of using the aggregate attribute is that you can specify the aggregation function to multiple columns at once, all at once. So you will get the result like this. But you have to rename the columns because it only transform the data inside the column, but the column header have not changed. Okay, and you can specify multiple columns and aggregate with multiple functions. But in this case, you will get if you will get a pivot table, and if you reset index to flatten that table, you will get a table with multi-index. And I combine the two index back together, so I get this. So I get mean value of the rating, standard deviation of the rating, mean value of the age, and standard deviation value of the age. Okay. 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 This. Okay. Sorry. This is the same. This is the same thing. So okay. When you are processing some statistical data, you might want to filter the outliers And in this case, I use the IQR, which will calculate the 25% and 75% quantile. And the range between these two numbers is called IQR. And this is a common method to filter out the outliers within the data. But I don't filter, but this is not a suitable data to do this demonstration, so I just calculate the IQR based on the current data I have. Okay, so you can compute your quantiles and you can merge them back to your data frame, and you minus these two columns and you get your IQR. These are the top 5 records of those data. Okay, and this final part, I demonstrate some okay, there's an example that I want to find top 5 ratings of each occupations. In the people, I want to find the type of the movies with top 5 ratings within each occupation. In the SQL code, you have to written like this is a I think this is a 3-layer nested SQL query, and this is very slow. Otherwise, you have to written it in written this SQL code using the temp table. But in Pandas, you wrote code like this. You first part you group by your data frame based on the occupation and the type of the movie, and the data you want to calculate the rating data. So you transform the rating data with the mean function. Okay, so you will get mean value of the ratings within each group, and then you will let me see. Okay. Okay, so but there is an assignment function here. So the transform function, the Pandas series, the transform function returns. It was assigned to this rating average column, and then you have a rating average rating value within each occupation and each type of the movie, and then you can only preserve these 3 columns and drop all the duplicated records, and then you sort it by order, and then you get the top 5 records based on within each occupation, and then you sort the values and print it out to get the top 5 the movie types with top 5 ratings in each occupation. Okay, so here's my talk. So do you have any questions? Yeah. Okay.
Data frame seems easy to use, but I'd like to know about the speed comparison between NumPy array or Python list and the data frame. Which one is the fastest?
Okay. You mean using NumPy array or using the Pandas?
Yes.
Right? I think it's for different purpose, because I use Pandas because it will merge data for me. And in the real world, when you are handling a lot of data, you might have to compare this data. One of the methods are to merge 2 tables using the keys, right? Yeah, and you can compare. You can get the matched results. So, but NumPy doesn't seem to have this kind of functions. Okay, but I believe those functions like quantile, or the function like quantile, you have a NumPy function called percentile, and I think that because the the data structure in Pandas is basically inherited from the data structure of NumPy. So I believe they probably call the same functions. Yeah. So I will use Pandas directly.
Okay, thank you.
If I understand, you first load from the table from SQL into your data frame.
Yes.
What if your database is very big and then you may not be able to load the full table into your data frame? Does Panda provide a kind of OM like to just filter which one you want, or you do in preprocessing with SQLite query?
Because in my work, I will use the I will try to query the data. I will not query the data directly using the Pandas. I will using the some developer environment for SQL, and using the SQL code, I will see I will see how many records inside this data when I use the query code I wrote. Yeah. So before I written Pandas code, I have a rough understanding about the amount of the data. Okay, before I wrote Pandas code, because I used Pandas for the logic part, not to query the data, not just to query all the data. Okay, so I will filter out some data within the SQL code, and Pandas and Python just handle the logical part that I want to manipulate, the data that I want to manipulate. Yeah.
Yeah. In real world, we have different type of data source and might have to output a different type of the format. Just want to know your suggestion. Do you have any preference intermediate storage like a file, CSV file, or the database for the intermediate data handling storage?
Okay. Okay, so if you pull data using a SQL query and you pull the data into a data frame, okay. Normally I will store the data into the binary format. It's called if you look into the Pandas file Pandas documentation, you will find it can output the data into a HDF5 format. It's a binary format that preserves the data type, that data frame used to store the data. So if I directly output the data into this binary format, when I read it back, I have exactly the same data frame that I used. Okay, but I think you have to look into the data that you probably retrieve data from different data sources, probably from Excel, probably from MS SQL Server, probably from Oracle SQL Server, or something else from maybe a RESTful code. But before you aggregate them together, I think you have to observe these data first to understand all the types and what kind of data inside these different data sources, the data you acquired, and so that when you continue the data analysis, you know what you are dealing with. Okay, but I will store my data to a binary format. I think the Pandas will handle the type of the data in the binary format. So when I read it back, it's the same thing. Okay. And I have also built a web service for the reporting, and in that case, I will store the analyzed data, the results. Okay, the reduced data into a MS SQL Server. That's just for my reporting service to query, and other reporting service to query, such as Tableau. Okay, are there any other questions?
I'd like to ask, for example, about big data support for data frame. For example, I have a very large, SQL table, and I can't load. It's basically the same question as he asked. Does data frame have some kind of streaming support? For example, it gets a handle to the database, and when you do the transform, it remembers the transform, but it does it lazily. It doesn't happen in real time, but
Okay,
when you retrieve the data, it performs the transformation, and you read because you need the data once. So it's some kind of like a streaming support. Pandas has this kind of support for big data processing. When you can't load all the table into memory, what would you do, or you have any?
I haven't looked into it, but I think if you have if you want some big data support, you probably will choose the data frame in other packages such as PySpark or Spark. As I know that the Spark 2.0 has data frame structure within it, right? So I think they have the support for the lazy evaluation. That's what you want to know. Okay. So, but in Pandas, sorry, I haven't looked into this question. Okay.
The syntax of the Panda seems more easy to be used than SQL syntax. But I have a question about the speed. Do you have any experience about if we have some very complex aggregate function? How about the speed when comparing? I do the complex aggregation function in Pandas and compare with the speed. I do the same thing in SQL.
Sorry, I don't have the similar data because when I use this Pandas, because the data is too large to handle in our server, because the server is public. If I do that in the server will crash and everybody else can use it. So I put data back into Pandas. And in other cases, the data is a very small amount. I can do that very quickly both in SQL and in Pandas. So I don't have that. And besides this, if you want a clear measurement of this, if you try to compare this with SQL code, but the SQL has to pull data out from its storage, right? And there's another latency there, so you cannot compare two of them directly. Yeah, it's hard to compare the two of them directly.
But in my experience, if I get some performance problem in the SQL Server or some DB, for example, Oracle, we have many tools or many methods or regional conference, Oracle, Microsoft to tune the speed.
Yeah.
But do we have any, if we met some performance problem in the Panda, we will have any tools to help to tune the performance?
The performance. Okay, I tune that manually. Okay, I will try to use different functions that compare their speed. Okay. The only problem I encounter here is the if you are using the nested query in a SQL is very slow, but actually you cannot use that. Nested query in a SQL code is very slow. You can find that on internet, right? Okay, but about Pandas, the only problem I encounter with the Pandas is that the memory space is not enough, because it's in some data type, maybe string, it probably stores a PyObject. Yeah, so it uses larger memory space. So I have to be very careful about the amount of the data I queried. Yeah, I do that manually. Yeah. Are there any other questions?
大家请大家掌声，就是在谢谢总汉。那
Thank you.
现在是